join me in welcoming Andy back to the University of Michigan for the first of what I'm sure will be many conversations enriching our community.
Thank you, Barry, and I hope everybody at some point has the chance to have the former advisor introduce them at a talk. It's a really lovely way to start a Friday morning. I'm just delighted to be back. I have to say, I've given a version of this talk in a variety of different settings and so forth. I thought for this one I'd like throw some curveballs and wrestle with some ideas and sort of do it publicly with you all. That is engendered is an increased sense of nervousness when I'm giving this talk. One, coming home for the first time and talking to some old and new faculty and colleagues, and then also wrestling with some new ideas. So I hope a little benefit of the doubt as we sort of like wrestle with some of these things together, and hopefully a little leeway if we're trying to like figure out how do I re-engage my Michigan colleagues now as a professor as opposed to a student. So the title of my talk is Analytics as Humble Measurement. A couple of examples, and then some implications to hopefully draw from these examples. How many people are familiar with this term? Quick show of hands. Yeah. I was not until, so do not feel that you're out of the loop or anything like that. I started working with some developers and they were mentioning that today's my yak shaking day. Alright, so I had like Wikipedia for a while, and like as all like developer related things, it had something to do with Krumm history, I guess. But the basic idea is that any apparently useless activity, which by allowing you to overcome intermediate difficulties, will allow you to solve a larger problem. Some would call this intentional procrastination. And in this case, what I want to do is draw some connection between what yak shaving could mean and a little mini dissertation I want to do around measurement theory. Because I think grounding some of what we're going to talk about, both in my talk and followed up in the later posters and so forth.
How do we think critically about learning analytics and the use of data to measure learning and then to take action on those different measures? So again, bear with me in terms of some general yak shaving, and we'll all engage in this collective activity. So broadly speaking, measurement is the assignment of numbers to categories of observations. It's a very general definition, but it's a really useful one in terms of just getting a sense of, in this space, if I think of a ruler, if I think of my mile per hour, like there are different ways I want to quantify things in front of me. And the benefit of that quantification is that we get to do math on it. And math is useful because we get to make comparisons. We get to visualize, we get to summarize information that is otherwise hard to summarize using language, discussion, video, audio, etc. Now, one of the implications we're talking about measurement theory is that combined with how that math gets used, that's what is generally referred to as sort of measurement science. It's a contested terrain both in the physical sciences. Physicists wrestle with these same problems to the same degree as social scientists do. And in one way that you might hear it referred to in different walks of life is what is meant by operationalization. So what do we mean by a specific quantification under specific circumstances? So in the social sciences, measurements are typically made in relation to latent constructs. And the idea of latency is that it's sort of hidden from immediate experience from us. And this definition from Mark Wilson, who is a well-known psychometrician out at UC Berkeley, the property of latency means that the element to be measured remains hidden until the circumstances are constructed, or the elicitation for measuring or eliciting that construct. And we're going to map that back to and forward into our interpretation. And together, the circumstances from which we're drawing our observations, and then the interpretations we're making is how we make those numbers meaningful. So how a measure is going to be used has dramatic implications for understanding its quality. I think many of us are familiar, well, is that a valid measure? And that's sort of an impoverished way of talking to many because it's valid for what purpose, under what circumstances? Is it predictive validity? Is it construct validity? Is it consequential validity? There's many flavors of validity. And that's sort of captured in this idea that really we can only assess how good a measure is if we think about the purpose to which we're going to put it. So Solberg, Moser, and McDonald have this really nice framework for thinking about different measures, especially in applied settings like hospitals and schools, where we have measures for improvement. And some basic ideas around like what's a measure for improvement entail, what does that look like? It's useful typically for a local audience. We're going to assess a small change. The instrumentation itself is typically brief. It's a small survey is one way of thinking about it. And it's readily and easily interpretable. We don't need to do a factor analysis to make sense of the quantification. It's sort of like, did you have a good day today, yes or no, is a brief improvement-focused instrumentation that we can quantify very easily. That's slightly different than measures that we're going to use for evaluation. Typically a broad audience. How does U of M compare to other Big Ten schools? How does this school compare to other schools? How does this teacher compare to other teachers? And we're typically using that, again, synonymous with evaluation, is the idea of accountability. We want to render some decision in order to add or subtract resources. It's typically done in a summative way. So a bunch of stuff happens, then we're going to measure, and then we're going to create a distribution, and this is good, this is bad. And the emphasis for that particular instrumentation, and when we do that, is we need a highly reliable quantification of what's going on. We might not be able to understand that number. Think of the GRE. Think of the SAT. Think of a variety of statewide standardized tests. If you actually talk to somebody from ETS, they're like, we measure mathiness or readiness. Like, I actually can't tell you specifically what Andy knows based on a GRE score of 632, but I know that 632 is higher than 631. So if I need to like let somebody in, or if I'm going to evaluate a master's program based on the average GRE score, yeah, 550 is higher than 520. And that's the real utility of it, is like not necessarily interpretability, but reliability. That number, I can get it multiple times. If I test Andy multiple times, it's going to be within a nice little tight range. So that's evaluation. And another use, one that we're pretty much all familiar with here, is research, where the audience might be large, it might be slightly smaller than one for an evaluation context, but it's largely a scientific community where we all have like sort of shared understandings of what a good process went into developing that measure or that analysis. And what's interesting here, and what's slightly different than some of the evaluation work, is instead of trying to array somebody in a distribution to say better or worse, we want to use these different measures to identify unique sources of variation in relation to a theory. So thinking about like some of Jacqueline Eccles' work, it's not that we just want expectancy and value in terms of measuring motivation. What if we added cost? So let's see if I can have a cost measure that like teases out some unique variation in understanding motivation. So the emphasis is to use theory and identify unique sources of variation in relation to these latent constructs. And of course, construct validity in this. Are you measuring what you're intending to measure is a fairly central emphasis in that work. There are other forms of measurement, assessment, diagnosis, but I tend to find that these three, improvement, research, and evaluation, they explain about 80% of the variation in, like, if I'm thinking about what is the number and how is it going to end up being used. So with those three broad categories in mind, and it's typical to think of like, well, what's the worst case scenario? And Sam Messick, who is at ETS and has done a lot of work both in his role there and then in supporting different federal policies, drew this distinction in terms of thinking about the negative uses, and I bolded like the two really interesting ideas in this longer paragraph that I think will have implications as we think about what are we doing with some quantification, some measure of learning that we're gathering from a learning management system, from a MOOC, from an educational game. And the two things he highlighted was construct underrepresentation. So if I say I'm going to measure your motivation, motivation's a big idea with many inputs, many outputs, but I might only have purchase on a few elements of that construct. And if I'm going to render a decision on whether or not I'm going to do something based on that measure of your motivation, I better actually represent that construct fairly well. And then another sort of kind of flip side of this is construct irrelevant variance. If I'm going to measure something and I'm going to make a decision based on your motivation, I better not be measuring other things. I'm hopefully have the purest measure of what it matters in terms of your motivation. So I'm either underrepresenting the construct, or I'm grabbing too much extraneous noise when I'm trying to measure the construct. And if we're going to render a decision on it, let's make sure that the numbers that we have some idea of what we mean in terms of how well we've represented and how much extra noise we've added into our measures. So construct irrelevant variance in the context of digital learning environments. So here we have a student who's going to interact with an LMS. Those LMS events get logged. They can be then later extracted for analysis, which is probably what many of the posters and many of the examples I highlight sort of follow this general trend of someone interacts with the technology, that data gets looked at later on. So construct-irrelevant variance starts to enter into our eventual downstream uses of these measures by adding variables into our operationalization that can add noise. So like, just because we have this event doesn't mean we need to use it, even though we typically have the event and we want to use it somehow. And then there's construct underrepresentation in terms of this space, where in many ways, if you've gone to ITS, as I've done in my time here, or if you go work with a different for-profit or non-for-profit technology company like Khan Academy, you can only work with the data they're collecting. And so in that respect, you can wildly underrepresent that which you're intending to measure, because they've spent, and many guys and gals have built a data architecture that's going to collect these events and these events only. And if you're going to limit yourself to working with those events, you run the risk of underrepresenting that which you want to measure downstream. So to bring back an earlier point in terms of like thinking about those circumstances, how well then do we understand the one-to-one learning task? So the student interacting with the LMS, what's going on there, and then the broader instructional system in which that technology is being used. Is this just a place where homework is put and you just do homework, or is this the place where you're intended to read, then practice, then do the homework? Is this something where these are voluntary assignments? Is this something where participation is graded? All these instructional elements are going to help us, or should help us, make sense of whether or not we're actually measuring something we're intending to measure and measuring it well. All of this boils down to, in one way, shape, or form, to kind of thinking about our use of data and our use of measures as an argument. And Bob Mislevy, who's worn many hats, he was at ETS, and Geneva Hartle, who was at SRI, has this really lovely definition and really lovely way of thinking about the use of educational measures, which is to call them an evidentiary argument from what we observe students do, say, or make in particular circumstances, to inferences, to claims that we want to make about what they know, can, or do, or have accomplished more generally. So how do we structure these arguments in relation to construct underrepresentation, construct irrelevant variance, circumstances, and then those future forward implications? Bob refers back to some of Toulmin and some of the ways that he sort of talks about structuring arguments more generally. We have a claim. There's evidence that we use to support that claim. There's warrants that help sort of form the logic between our claim and our evidence, and then there's certain backing that supports that warrant. And there's actually many more elements the more you dig into it, and if there are any rhetoricians in the room, I do apologize. But for my purposes, we can take some of my previous comments, start to array them into these more familiar frameworks from Toulmin. So our uses are our claims. I want to make a claim in relation to this school, this teacher, this measure, this improvement approach. Our warrants start to bubble down or boil down into these elements of methods and methodologies that we apply in our different social science backgrounds. So what is the process for developing the measure? What different modeling frameworks are we going to use? Why is the p-value useful? It's actually essential. That's the warrant, like the logic of why that p-value as evidence for your claim sort of falls into a statistical idea of like our observation is due to chance to this degree. And then prior research and theory is going to help us sort of support these different logical chains that we're trying to make. And the underlying evidence that we're working with are those ones and zeros and those different event structures from our learning management systems, the data elements, and then as Bob and Sam Messick were pointing to, the task or the circumstances in which students were engaged in those tasks. So I want to try and sort of get past some of that yak shaving, some of this initial sort of baseline information around measurement theory, and jump into two examples, and then open up for some implications. So the first is from a quality improvement project that I did with a school district. The title of the project was a partnership-based approach to measuring learning behaviors using event data. And this was a partnership with the district, funded directly by the district, and they gave me permission to talk about some of our work together with you all today. And the driving question under this project was, how can we use data from a learning management system to measure and better understand students' learning behaviors. And their emphasis in this project was, how do we democratize access to what does it mean to be a good learner in our schools? This district in particular serves a broad population of students, and there was a concern that the more moves that they made toward digital curriculum and digital uses in the classroom, that it would be leaving certain students behind who didn't have experience with this prior to coming to their school. So what can we learn from students of the past to help students who are new to our environment understand what does it mean to be a successful online learner? So we wanted to identify these behaviors and then feed them back to the individual students. So the process that we went through was a collaborative one where we worked with the school staff at multiple levels of the organization to talk to them. Like, what do you consider to be useful behaviors for students to evidence? Just from your experience watching students, or just from your background being a teacher who's interacted with multiple students in your time? And we used that to sort of identify key moments within the learning management system. Things like, wow, something that happens after an assessment seems really important. Something that happens before an assessment seems really important. Something that happens at the start of the week. Why? Because in their context, they have these mentoring sessions that they set plans for the rest of their week. And then it wasn't just like having a bunch of conversations. We wanted to turn this towards some evidence base related to the methods we were going to use to derive these measures. And so we correlated these different measurement ideas that came from faculty and staff on the front lines with assessments. So if you think this is a good behavior, let's correlate it with how students have done in the past, and that'll serve as some evidence that we might be onto something. And we looked at all students in the system, all subjects and all grades, because we didn't want to just identify math behaviors or just identify science or ELA behaviors. So within the LMS, they have something called a playlist. And that was our unit of analysis. And I don't want to go too far into this, but it hopefully will paint a little bit of a context for you. There was a pre-assessment on every playlist. Then there was a bunch of objectives, and underneath an objective were the different resources that students could interact with. And at the end was a summative assessment. And you had to pass the summative assessment. And there's a great deal of student volition in terms of, I don't need to take the pre-assessment. I don't need to jump into the resources. Really, all my teachers are expecting of me is to pass the summative assessment. So we had this wide open task. So to draw back to some of Messick's ideas, the circumstances under which we're going to draw some measures of students' learning behaviors, the system didn't force them to go 1, 2, 3, 4. They could jump in at any point. They could skip playlists altogether. So we had a great deal of student volition that we were trying to quantify. And there are on average about 10 of these playlists for a given course. And you must complete all 10 in order to sort of earn the final grade. So it's kind of like a gatekeeping mechanism. Pass them, and then we'll look at all of your assignments and we'll create your distributions of A, B, C's, and D's. Typically about 5 courses per student, 3,000 or so students. And then within a given year, we had 3 years worth of data, about 3 million observations from the individual assessments students were taking pre and summative, and then the individual resources that students were clicking on. So as I mentioned before, an important part of this claim I'm going to want to make in relation to what we're measuring is the backing, sort of the theoretical support. So we did a deep dive together, and we worked with the individual school to help them gather these resources, make sense of them together. So we looked at a whole bunch of learning theories to figure out things like different ideas for variables. On the left, on my left-hand side, the benefits were ideas for variables, different modeling frameworks that other researchers have used, relevant task features, what are we going to pay attention to in terms of students' use of a playlist, and then overall building this argument. Some folks think in a very similar way, so we tapped into those authors who had thought about measuring related things in a way that we were as well. Kristen DeCerbo, for example, if you've read any of her work on perseverance and so forth, built on very much these ideas. So we drew in and we dove into some of the theory and research to better understand what we're measuring and why. So to give you a flavor from some of the insights from our teachers, they're kind of oddly edited by me, so if there are any odd constructions, it's my fault, not the teacher's fault. But this basic idea of passing a pre-assessment before taking a summative assessment, and that feels like a good thing. Can you operationalize that in the event data? Can you correlate that then with end of that assessment outcome or end of course outcomes to know whether or not this idea I have about doing the pre-assessment before actually has any evidence behind it? So look into that. Do not repeatedly take summative assessments. So is there a way that you can quantify, looking at the event data, students who are repeatedly taking the summative assessments? Maintaining a proper balance between resources and assessments. So if you're going to struggle, that's fine, but we also want you to struggle while you're trying to learn, and that meant using some of the resources that the teachers had provided for them on the playlist. And I won't go through all of these, but the last one is like to start a playlist, for example, with a resource or pre-assessment. Don't jump straight into the summative assessment. So these are ideas. We all like sat in rooms, not as pretty as this, but we would talk about these different ideas, and then we would try and hack them up using the event data to see, yeah, we can meaningfully operationalize that. So here's a device that we used quite a bit, which was to take what the event data looks like coming out of a query in a CSV file, and then array it in a way that's just going to be much more friendly to our teacher and administrator audiences. And we produced dozens of these things, and I will sort of point to an important way in which these served as our overall validity argument, but the basic idea here is, what's the academic day of the year? Far left, going this way. Per playlist, this student on day, 17 started with a resource. Day 18 went to a resource and then tried to attempt a pre-assessment. That's what the P is for. Failed it, that was red. The day after that did resource. Then took the pre-assessment again, passed it, felt good about his or her performance, jumped into the summative assessment, S, failed it, followed up with a resource. The day after that, logged in, found a resource, and then passed the summative assessment. Looking at this, is there any claims that you want to make, or is there any representation of students' activities that sort of jump out at you in terms of students started this playlist, ended this playlist by passing the summative assessment? What kind of claims or what kinds of ideas bubble out of this representation? Yeah.
If I'm reading it correctly, the more a student engages with resources, maybe the more likely they will be to pass.
Exactly.
If I'm
Yeah. And so like these kinds of ideas, we put this, ask these questions, and folks would in a very similar way say, well, I noticed that actually after they failed, they went to a resource. Well, that's an interesting behavior. And then they didn't do anything after that. Oh, I wonder what happened. And then when working with teachers or administrators who are actually observing these kids, like, oh, I'm guessing the lab time ended and they had to go, or maybe they moved from math to English. Can we capture that in any way, shape, or form? So this simple representation would evoke all of these different ways of thinking about students and how they interact with the LMS. And what we had teachers do is not only use these to evoke a better sense of students' activity and how that relates to events and how they're logged in the system, we also then had teachers code each one of these. Is this a good use of this or is this a bad use? 4, 3, 2, 1. And then I'm going to make a measure later on, and I'm going to correlate my quantification with teachers' ratings of whether or not this is a good playlist. So a really simple piece of correlational evidence to sort of support the constructs that we're trying to measure. Oh, yes, Stephanie.
On that fact pattern, my question is if the intent was to use the pre-assessment and then the summative assessment as a measure of what did they know before they started working on the content, the fact that the pre-test is so close to the summative and they did all the resources, it's almost like they did all the resources for the pre-test. No. So would a pre-test summative difference be?
So what's interesting here is looking at, we're just going to care about this final summative score operationalized in a very specific way. We're going to take your total points earned divided by the total number of attempts. So the more you attempt it, the lower the sort of contrived summative score is going to be. And what we want to do is compare that with all of the behaviors that preceded it. And what's interesting about the task or the circumstances under which we're measuring this is volition was okay here. This wasn't a tightly constrained task where you can only use the pre-assessment once and you have to use the pre-assessment and you have to use these resources. The goal was simply to pass the summative assessment. however you want to. And what we were trying to surface in looking at the different events is, are there patterns in how students actually move through these different playlists in a consistent way that we can share and highlight with other students? So in some ways, we're not necessarily trying to predict performance per se. We're looking at different behaviors that might have led to more or less successful completion of the playlist itself. So we ended up coming up with about 10 operationalizations of this, and we correlated it with the summative assessment scores at the end of each playlist, and then did a little sort of factor analysis because we wanted to create a composite score. If you look at individual scores, that's pretty noisy, so we tried to look at the shared variance across 4 behaviors. And we came up with this sort of, as we all do when we sort of squint at scree plots and so forth, and eigenvalues, like, oh, that looks like students adequately preparing for assessment, and we all talked about it, and we felt good about that operationalization. And what was nice was this factor score we generated from these 4 behaviors correlated with our teachers' ratings of the behaviors, and then it also had sort of nice correlational evidence related to the overall score on a given thing. So 10 of these behaviors, one of them was like 14 points. If you evidence this behavior, on average, students score 14 points higher. If you evidence this behavior, on average, students typically have like 8 or 8.5 points lower on their summative assessment. And then you roll these up across 10 of them for a given class, and we get a nice little bump in the overall grades that students were earning as well. So this was within a smallish scale, partnership between us as researchers, them as practitioners who are trying to solve this problem. How do we democratize access to what it means to be successful in our school? And so we gave them this list of 10 behaviors, and sort of they're talking with their students and how they can use them and how those students can evidence them as they are working through the learning management system. So if I put it into my Toolman argument framework that I introduced a second ago, my claim is that I can adequately measure students' adequate preparation for preparing for assessments. My warrant for this, actually I'll start with my evidence for this is the factor loadings of that composite score, the correlation with teacher scores, and the correlation with desirable outcomes. Now that evidence is sort of free-floating until I tell you, oh well, factor scores are meaningful because of this. The process of working with folks on the front lines is really important because we generated their insights. So the factor analysis, the hierarchical linear modeling we did, and then the prior research. So I can't just come into a room like this and say, hey, I can measure students' adequate preparation for learning in all learning management systems across all time. It is in this very specific setting, using these tools, using these events. Here's my evidence and here are my warrants for whether or not you think we actually did it in this very particular context. So hold on to this idea of like particularity and sensitivity to context as we move into our next example, which was done with the Carnegie Foundation for the Advancement of Teaching, where we're just trying to predict students' likelihood of not passing the course at a very particular point in the academic year. So again, it's another quality improvement project. Wanted to identify students who were earning a C or higher, or who were not, earning a C or higher. And we worked with folks at the foundation and then with different faculty members in the community colleges. And our evidence-based approach here was some exploratory data analysis where instructors participated with us in the data analysis as well as predictive modeling workflow. So we used Carnegie Mellon's OLI. That was the platform that was used in these particular courses. We had 54 instructors, a bunch of data coming out of OLI. The theoretical supports were a little bit less here, but intentionally so. Our goal wasn't to measure some interesting construct or describe some interesting composite set of behaviors. We had a very perfunctory, we had a very specific thing. We were just trying to predict at week 4, what's your likelihood of not passing at week 16? Theory can be useful, but it was not central to our investigation. We're not making a claim about measures of learning. We were trying to predict an outcome. So here we used our theory to, again, identify different variables to pay attention to, and then to think about different modeling frameworks. So prediction, much less on the theory. It's going to be much more on our cross-validation strategies, the different holdout data sets. That's going to be central to our warrants. Whereas in the LMS case, I wanted to measure a construct. Well, what theory were you drawing on? How did you operationalize those things? Who participated? So different claims that I want to make, prediction versus measurement in terms of a construct, and the different ways in which we use theory as we went along the way. Had 4 different feature sets Again, this is all going to serve as more and more of our warrant for the evidence that's going to generate the predictive validity of these different measures. Here are the 4 different data sets that we tried. Things that were very granular, 52 events. In one model, we used 9 different variables. And our results, this is a performative table. If you want to classify this, we're not going to dig into this in any way, shape, or form. But one of our models, one of the algorithms that we used, a logistic model, with one of our data sets, had a pretty decent ai.umich score. So using one particular feature set and one algorithm, we were able to pretty well identify students who were not going to be successful at the end of the course based on where they were in week 4. But again, I don't want to get into the details of the modeling. It's more pulling back here to go, the claim I want to make with this particular data set and this particular modeling approach is that we can identify students in StatWay, which was the course that was used, at week 4. My evidence is our AUC score, and that they were all engaged in a common task. StatWay was organized across the pathways for homework and test preparation. So the way in which it was used was central. We didn't have people only using it in one way and another people using it in this way, because those different ways, those different circumstances are going to lend different interpretations for the events that we would try and eventually predict. And then our warrant for whether or not, why do you pay attention to 0.76 in the first place? Well, there are best practices related to developing predictive models related to cross-validation, use of multiple algorithms, use of multiple feature sets. So those 2 examples, one based on measuring learning behaviors from event data, one predicting likelihood of success using event data. I'm going to pull back on a couple of slides here before concluding and talk about what did I mean by this somewhat odd title for a talk, humble measurement. And the central point here is, while research-informed processes, again, the warrants for what I'm doing, were used, humility is still required when going from one context to another. I'm not going to take my StatWay model and come to U of M and say I can predict at week 4 what your physics 101 students are going to be able to do. But I think there is sort of floating in the back of our minds, because we can produce data models, data products. This sort of engenders what I would call a false sense of security in that we've produced a product, therefore that product will be useful in another setting. And here, pushing back, there's all sorts of implementation and diffusion reasons why that might not be useful. I want to draw some connections to, actually from a measurement perspective, that way of thinking of we've done it in setting A when we can apply it in setting B, why that might not be useful. So how generalizable is my week 4 model here at U of M? That's a really open question. It's one that lends itself to testing it again with my different feature sets that are available here, with repeating our prediction algorithm and so forth. The work isn't done with model 1. Model 1 will help set up the second time someone wants to run that model here at U of M. And this implies a specific tension that I don't think is groundbreaking or new. It's just worth highlighting, that rigorous research designs, which is what allow us to make big claims, often conflict with local relevance. So if I want to say that this is good for all time zones, I need to have tight control over the study setting. I need to use multiple measures. I'm going to actually need to probably disrupt what normally takes place in your classroom in order to measure those things. And actually my intervention is an inherent disruption to what you were normally doing. And I need a bunch of redundancy, because I can't take a claim to a scientific or an academic audience saying, hey, look what I did, without people criticizing each and every single element of this. How well did you measure this? Under what circumstances did you measure this? All of that implies I'm actually going to get in the way of improving the learning environment of what's taking place at places like U of M and in our StatWay class. So hasn't this always been the case? Yeah, I think, of course, right? In all of our research methods, we talk about generalizability and so forth. But in our current state, thinking about, again, models and data products, there's this common fallacy of bigger data leading to bigger claims. And hopefully looking at some of the humility you need to apply in terms of developing an evidentiary argument that remains fallacious, that actually the size of the data set isn't as useful as the argument in which you put together related to your claim. And I think this idea of data products as portable products, again, sort of engenders this false sense that we've built something at Michigan that's going to work somewhere else. And I go back to some of Janet Weiss's use and sort of thinking around evidence use more generally. And most people would call a data product an instrumental use of research. Instrumental meaning, here's the thing, I'm going to apply it in another setting. Actually, it's closer to the other elements which she highlighted, which is symbolic. Hey, we're U of M, we've got fancy models, and I just feel better to the rest of my peers. And then conceptual, which is less sort of a negative connotation to it, which is I've looked at your model and I'm a little bit smarter than I was before. Maybe I should try that in my setting. But I know there's a whole bunch of work I'm going to have to do to make it work. So the implications from all of this is four bullet points. Attend to the claims one wishes to make. Is this something that you're going to say is good for all time zones? Or is it something that's just good enough to convince someone down the hall from you? Recognize the brittleness of a data product. You need supporting conditions. The learning needs of those who are going to be end users. Measurement science. So pulling back even the highest level of abstraction, I'm not saying follow all the rules. As folks in the room know, that's not exactly what I'm known to do all the time. But it's known like when to break those rules, and having the proper frameworks and thinking about, actually we're not going to care about reliability here because we have multiple assessments over time, and reliability is really a useful thing for one point in time. So knowing when to break the rules is an important sort of implication for thinking about the role of measurement science. And then just in general, interpretation, our use of these different data products are going to require multiple features that are just often taken for granted. How often have you actually thought about the test conditions of a standardized test? And what does that actually mean to get that number 720? Sitting in a room for 4 hours, right or wrong on particularly contrived questions, and that's the task, that's the evidence for which we're going to say you get into a college or not? We often take these things for granted because it's just culturally understood that a test is a test is a test. And we don't have those same shared understandings when we're talking about some of these newer models and so forth. I use Sam Messick's stuff, Bob Mislevy, Toolman, and others, and it's just a couple of lists of folks to think about as you're engaging in your own work. So with that, I will end with simply be humble and thank you again for having me back to Michigan. It was a great pleasure to talk to all of you, and I look forward to talking to you the rest of the morning.
Questions that have come in. Going back to an earlier part of the talk, how do you describe the difference between assessment and evaluation?
That's a good question. I would think the difference of evaluation is there's more of an implication to the decision that's being made, as opposed to I'm going to evaluate you on your goodness or badness, as opposed to just understanding what you know or don't know without that sort of added valence of good or bad to it. And you can play around at different levels of whether it's an individual person that's assessed, and then we evaluate programs. That's another way of thinking about it, but I think evaluation tends to imply another level of use behind it that I think assessment can or should.
And then, of course, context matters, but broadly speaking, are there data elements captured in the LMS that you've seen fall into the category of construct irrelevant, as in what's more noise than signal?
Logins.
Yeah.
Number of logins is by far the noisiest thing, because it's going to depend on what the instructor wants in that class. Do I want you to come? Do I post things that are actually relevant to your learning? Am I posting things that are going to be useful for course success? And then there are just students who like to log into things to keep track of stuff. So it just tends to be the noise. I don't have a good explanation for why someone's high or low without knowing a whole bunch about the instruction that professor's trying to accomplish.
One more question, anybody? Let's thank Andy again.